Hey guys, now we are going to solve question number 24. Let's see what the question states. The dipole moment of a circular loop carrying a current I is M and the magnetic field at the center of the loop is V1. When the dipole moment is doubled by keeping the current constant, the magnetic field at the center of the loop is B2. Then the ratio B1 by B2 is. So let's just start with the things that we know. We know by the fact that dipole moment mu is stated as NIA and A of a circular loop is given by pi capital R square and the value of n is x in this case. So we can simply generate mu, that is I into x pi r square, and as it is given in the question that if the dipole moment is doubled keeping the current constant, then r2 is root 2 times r1, and therefore the magnetic field at center of the loop would be B equal to mu naught I upon 2r. So after taking the ratios b1 by b2, we are going to compute r2 by r1. It simply comes out to be root 2 by 1. In this can be easily solved by this equation by taking the r1 in denominator, and our answer is, as you can see, is A part.